Good morning, everyone, and thank you for joining us with our webinar with Baicells. My name is Nicole Devereaux, Marketing Coordinator with MBSI WAV, and presenting today we have Cameron Kilton, Engineering Services with Baicells. I'd like to bring your attention to the chat window found top right of your screen. Please address either Cameron directly or everyone with any questions you may have throughout the webinar, and we'll do our best to answer all of those if time permits. With that said, I'll pass the mic over to Cameron and we'll get this started.
Good morning, everyone. I'm going to share my screen here shortly. Get this working correctly. Wonderful. There we go. All right. Thank you, Nicole. And so anybody knows, I'm Cameron Kilton, in Engineering Services here at Baicells. As we go throughout the webinar, by all means, do ask questions as it pertains. We will have a formal Q&A at the end for just some generic questions. But if there's something that we're covering at the moment that may pertain to something that is of interest to you, feel free to ask a question. I'll keep an eye on the chat box and we'll address it at the time. In the meantime, let's get started. First of all, thanks MBSI WAV for putting this on. I wanted to talk a little bit how Baicells is unique and in the sense of how it can help you all in the Canadian market. For those who have some perspective of where I'm from, in the Northeast. I'm actually in the state of Maine. So I'm familiar with a lot of the different topography challenges. Certainly not as cold as you all see, but that Arctic wind doesn't shield me either. So I do have some experience with operating that. I have owned and operated two different ISPs, both in the fixed wireless Wi-Fi kind of technologies, as well as an LTE-based ISP as well. So I have a lot of experience in and around that, and I'm happy to share some of that knowledge as we go through. So by all means, ask some questions in regarding to that, and I'll see if it will help you all out. So the agenda kind of go over, we're going to do kind of an intro to LTE. I know some of you here, they're probably already customers, and some of you that are first just looking into LTE. Then we'll talk about kind of why LTE and why Baicells naturally. We'll go into how LTE solves some of the non-line of sight challenges and the performance per hertz that you will see and speed per megabit and all that fun stuff. We'll have a brief Q&A. Then I actually have a special kind of presentation that I throw at the end that talks a lot about our Halo B solution, which is a fancy way of saying Distributed Evolved Packet Core, or otherwise known as EPC. And please bear with me on the acronyms. I'll try to break them all down. Just a few short years ago, I was a duck without water for a while trying to figure out what all these acronyms meant. But I'll break them down to hope everybody gets a good understanding of what we're talking about. So LTE basics. So a lot of people are pretty familiar with what LTE actually means now. It's long-term evolution. It's been around for several years, well more than that. So it first began in 2004 as part of the 3GPP standard and evolution of mobile and cellular technologies. Certainly a lot of increase in data consumption. We've all seen this throughout our customer bases today. We used to be able to plan, maybe a couple hundred kilobits on average per customer. Now we're measuring things in the megabits per second on average per customer. And data consumption is at an all-time high with all the streaming services that exist out there today: YouTube, Netflix, Hulu, etc. It's something that you're all fully aware of. A lot of the goals that I like in and around LTE and things that we get to take advantage of is higher throughput in many cases based on the scenario that exists, integration, handoff, lower latency, and overall end-to-end experience as far as the optimization of QoS and what's also known as QCI in the LTE space, and we'll talk a little bit more about that. So this is kind of a overview of what LTE is from a technical standpoint and how all the data gets from point A to point B. So long story short, if you look at your far left, you have UE, which is basically the LTE equivalent of the CPE. They just call it, UE stands for user equipment in the LTE world because, as you can probably imagine, customer prem equipment, otherwise CPE, doesn't really fit a handheld device. So LTE came on with a new way of just classifying that. So they just call all devices that the customer has interaction with a UE. So that's the far connection on the left. Then, of course, you got the internet to the far right. And everything in the middle is basically the magic sauce that takes place in LTE. You have the E node B, just to the right of the UE. That's essentially saying that's the base station, the access point equivalent, but in LTE speed. So E node B is essentially your base station. So you'll hear me use the term base station, ENB, E node B. They're essentially all interchangeable. Very seldom will you hear me use the term access point because I like to keep that reserved for Wi-Fi technologies. Then you can kind of see as you transgress to the right that the connection and signaling that happens. You have S1 MME, S1U, which is a user plane traffic, and MME is a mobility management entity that essentially allows the E node B to authenticate and become a base station on the network in live. It allows you to accept the signaling, which goes over to what they call the SGW down here for the serving gateway. Then, of course, you have the packet gateway, which then goes to the internet over what they call an SGI interface. A lot of that stuff you'll probably never need to deal with, and at the highest level, if you're using different EPCs or embedded EPC solutions, all this stuff kind of happens in the background. HSS that you see here in the top kind of middle, that's essentially the LTE equivalent of a radius server, where that's where all your speed plans can be set. Where you provision all the SIM cards, you assign them to different customers, and that's where everything talks to. From the LTE perspective, ends up talking back to the HSS to kind of get its instruction. So Baicells was very unique in the sense of coming to market. We came up with a cloud core design. Many of you that are seeing it didn't come without its hiccups, and occasionally we are still working through some various issues to speak of today. But what it did do is allow a very low cost of entry to get into LTE. Because for those of you that have had some experience looking into LTE, understand that an evolved packet core comes at a great expense, and that's usually anywhere between $100,000 and 1.2 million US. Then, of course, there's yearly maintenance on top of that. A good example would be I looked at a Nokia EPC, and it was about 1.2 million and $235,000 a year in yearly maintenance and updates. So they're quite expensive. Typically speaking. So it's something that we knew from our perspective that's not what most ISPs are going to be able to afford to fork over for cash. So Baicells came on and developed a cloud core technology where essentially it splits the signaling in two ways. We have the S1U and we have the S1C, and it splits that plane so the connection goes up to the cloud to do all of the authentication. But then we use a really cool feature called local gateway or local offload, where the actual data for the customer will go out your internet connection, but all the authentication goes up to the cloud. And you can see this is the current architecture that exists. The only thing that is not accurate is this bottom in the middle here. It says Baicells Cloud EPC East. So this is the redundant HSS system here is not in place, but everything else is redundant in the nature. And this one is the OMC Boss is our management platform, which I'll talk a little bit more about. So some more information on LTE. This kind of talks about the different channel sizes that exist in LTE. Of course, specific typically to FDD or TDD bands. So for most of the you here on the call are probably operating in band 42. Some of you may have some band 40 or band 41 licenses, and lucky you. But typical band support you're going to see from us is 5, 10, 15, and 20 megahertz. Which is the most common utilized band structure anyway throughout LTE. Very seldom is 1.4 and 3 megahertz used, and very recently even some narrowband LTE was ratified as part of 3GPP, which goes down to LTE even running at 200 kilohertz channels. So that's more for IoT kind of play, and should you have any needs like that, by all means reach out to us so we can talk about some of our narrowband IoT LTE products. different schemes, and you see modulation schemes, downlink, QPSK, 16 QAM, 64 QAM. Many of you that are operating different wireless technologies today are probably already familiar with different modulation levels. We're working up to an LT supporting up to 256 QAM on the downlink, which will certainly push for significantly more speed than you see today. A lot of our radios, skipping down to the peak data rate on our FDD systems, we can do as much as 150 megabit on the downlink and 75 megabit on the uplink. And our TDD radios on the same 20 megahertz channel, we can do about 110 to 112 megabits downlink to up to as much as 20 megabits uplink on a single 20 megahertz channel with a 2x2 system. And of course, there we go. So there's different frame configurations that are part of the timing mechanism, particularly as it relates to TDD, and I'll talk more about that. So if you have other operators that are nearby that happen to be operating LT, this is where it becomes really fun and kind of exciting in the sense of you're able to get close or at least almost identical to the timing that they're using with their GPS system. So that way you can have the ability to kind of use similar frequencies to make sure you're not causing interference with them or them causing interference with you, or even self-interference. You'll be able to time your entire systems together based on different subframe and special subframe configurations. And we help you with that and essentially make sure you match up as best as you can. And we're continuing adding some additional subframe support to support other technologies such as those that may have Huawei or ZTE networks. We want to make sure that you can time with those as well. And our offsets are generally pretty flexible from what we can configure there. Any questions so far? I expect there'll probably be one or two. Okay. Well, we'll keep moving on. So why LT? LT is the global standard. I'm not going to read this all to you, but it's heavily supported throughout the entire world, and there's a lot of equipment available, a lot of options available. The reason LT is being looked at, particularly in the rural areas and the non-line of sight areas, is it's just too costly to get fiber in there, and Wi-Fi-based chipsets come with some certain level of unreliability. Now, before you think I may be jumping on just LT only, keep in mind I have deployed all of these technologies. I have a lot of background with Cambium, with even Trango going way back, BreezeCom, Alvarian, and various others along the way in my career, having deployed many of them. And they certainly have had their uses, but what you'll find here now is we're going to get a little bit more performance out of LT, and we're certainly going to make it more attractive from being a little bit more standard and allow you to have some more flexibility as you continue to scale your networks. The scheduling in LT is significantly more enhanced over Wi-Fi as far as the amount of users one system can support by comparison. So LT can grant you more users to internet access on all their devices quicker, reliably, and more cheaply, and standardized much quicker. So one thing that made Baicells very unique compared to a lot of other companies out there is we rewrote a lot of the LT stack. And the reason we did that is if you look at LT from kind of inception to where it is today, a lot of that code was there for backwards compatibility, working with 3G networks and making sure everything would hand over correctly. Well, now with technology primarily just in LTE and now moving into 5G, is we didn't need a lot of that extra code, which means we had to increase a lot more processing power, which means the units required more power draw. They were much larger. Now, there's a lot about it you didn't need. So we stripped a lot of that nonsense out based on what we've learned and made it more efficient, less power consumption, and which also reduces the cost of components. So we're able to pass that cost down to the consumer, which is kind of a win for everybody. So by contrast, and you see our competition still use much larger radios, bolting top new features on top of old features because they're still maintaining older technology, which just really isn't needed anymore. So we did take some time, like I said, and we rewrote a lot of that stack. So this is one thing that kind of has changed recently, but I still put it in here because it gives me a moment to call it out, is, you know, our headquarters, our world headquarters was in Beijing, but for those who are following our press releases and things like that, we actually just announced the relocation of the world headquarters to the U.S. It's moving to Plano, Texas. The reason that is actually our North American market is our biggest market. And we knew in order to continue to support the customers that we have here that we needed to have more of a foothold. So we're moving a lot of our engineering into the U.S. and other parts of North America to help support the continuing growth here, which has been quite significant. We have a lot of carrier deployed products. We actually OEM a lot of our product to other manufacturers as well. So there's going to be some times you're going to see some products that may look a lot like a Baicells eNode B. Chances are it is. So, but for various contracts and obligations, we can't confirm nor deny that that actually exists. We didn't invent a lot of the fun stuff that is going on. However, we had to make it more efficient. So we're able to make it much more economically viable for you to help continue to grow your networks and be more cost effective, especially as it plays towards the fixed wireless deployment. When you look at the major differences between a mobility network and a fixed wireless network, is one is the significantly more mobile users, so the cost per benefit is much different. But in a fixed wireless application, with data consumption being the way it is, which is also why you hear a lot of companies globally offering quote-unquote unlimited services, but we all know they get throttled after a certain amount of data consumption. They're never really truly unlimited. But in a fixed wireless application, many of you are offering unlimited or unmetered, or at least a very high data consumption cap before they start getting either additional billing, usually in the hundreds of gigabytes kind of data consumption, versus most carriers are anywhere from 10 to 20 gigabytes before they start really hitting you with the extra bills. So another part that you'll come to find is unique with Baicells is part of the ordering mechanism. So, I don't like to use the term plug-and-play deployment. It's, we've all been through that scenario before. I usually use the term plug-and-pray. There's always a little bit of things you have to learn when you first get into this. So if you're new to LTE, as much as it says LTE is easy as Wi-Fi, it's simplified like Wi-Fi is what I will say as far as a programming perspective. But LTE is still a very, very complex animal, and you should treat it as such and take the time to actually read the documentation that we provide, and that will certainly help you. But by all means, if you do get stuck, we're here to help get that up and going. But what we have done is simplify by comparison. A lot of eNode Bs that exist out on the marketplace are all CLI, and may CLI live forever, but it is very complicated to program many radios with CLI. So we have simplified it to essentially a couple web GUI windows where you can go in, you can select your frequency, your channel width, your frame configuration for GPS timing, essentially hit save, reboot, and you're off and going. That's obviously a simplistic way of explaining it, but it does give you a kind of good overview. Another benefit that I have found, having been an operator and now being a manufacturer, one thing that Baicells does that I actually was kind of surprised about when I first joined the team is that they include essentially everything you need in one box to get off and going. You get the GPS unit, you get the radio, you get a power supply. The only thing you don't get is essentially the coax and antenna and the power cable. You have to supply and data cable. But typically speaking, if you were to go source other products from other companies, the GPS isn't included. Any of the patch cables for that's not included. The power supply is not included. We even gone so far as I think there's even a roll of electrical tape and mastic in every box too. Which, and for those that are buying some of our new products, we even include cold shrink, which is one of my favorite things to use. Oops, wrong button. So connecting more or less is kind of our new slogan that we've been doing. Is we're able to do a lot more with less amount of money, which is kind of the big thing. I have a soft spot for rural connectivity. That's kind of what I've done my entire career, which I think is the reason Baicells was interested in me come join, is kind of bring that the recent operator's point of view, having serviced a lot of the islands off the coast of Maine, as well as going into the northern mountainous regions, and serving those people that are heavily forested and hard to get a hold of, and doing so in a way that makes sense. Granted, I have a soft spot for rural connectivity, but I still need to make money while I'm doing it. So we have to keep that in mind. And it can be very easy to get distracted by cool new tech, but it also comes with a price figure that you have to be cautious of. So trying to make this ubiquitous, green, and one thing I say by green is you've got to watch out when you're shopping around for technology now is how much power draw are these things taking. And one thing I've found with from LTE, most of the equipment is quite intensive as far as how much consumption it is. But Baicells is one of the industry best ones I've seen out there. So by comparison, one of the 10-watt radios I was working with Alcatel-Lucent was about 350 watts of power consumption. That same radio we make a 10-watt version of is only about 110 watts of power consumption. So we're almost a third, or actually about a third less power consumption, which is a real figure, especially with power costs generally on the increase, not so much on the decrease. So that's something to keep in mind, and makes it more affordable to find the likes of solar solutions if you're in a really remote location where solar you can't really think about in a typical macro deployment. But when you get lower cost or lower power consumption E-node Bs, solar becomes more of an economical solution that makes more sense. So as of October 2017, we have over 450 worldwide deployments, of that which 300 or more is in North America. So we are very, very busy here in North America. We have over 25 products and growing, and there's a couple more I'll talk about to kind of give you some teasers of what's to come towards the end of this webinar, because that's always one of my favorite things to talk about. For those who aren't aware, I actually just got back from a 10-day trip over in China at a couple of our different offices there to work on some of our new and upcoming products. So I will throw a couple teasers out and what we're up to in that regard. We have over 300 patents, and we're closer to 420 employees now. And so if you do the math, we are, I think it's like a 1 to 1.25 patent per employee ratio, and we have a lot of R&D engineers, more than 75% of, and it's probably closer to 80%. So some of our products that we're working on, a lot of people have been asking for and up and coming here is our 4x10 watt radio. So this is a dual carrier 10 watt radio. And a lot of people have asked us, and this is a good time to call attention to, is how come we don't make a 20 watt radio? And they said, well, we can, but what you're really getting at a 20 watt radio, particularly if you add carrier aggregation, is you're actually getting two 10 watt radios. Because anytime you add carrier aggregation to a statically defined piece of hardware, and for those who aren't familiar with carrier aggregation, this is one of my favorite things about LTE that I'll talk about, is if you need more throughput on a Wi-Fi based system, what do you do to get more throughput to those customers? Generally speaking, do you increase your channel size? And that's usually the go-to in a Wi-Fi based solution. You go from a 10 to a 20 megahertz channel. For some equipment that can support 30, you do that, but often it's going from 20 to 40. So when you do that, you actually give yourself a bit of an issue in the sense of your receiver sensitivity. When you double your channel size, you lose 3 dB of receiver sensitivity. So what LTE did, in order to achieve the same performance without actually losing their sensitivity, is they're able to bond channels together, but they still operate independently. So dual carrier, or carrier aggregation, is taking as much as either two 10s or two 20s and bonding them to appear as double their size. So you could have two 20 megahertz channels that operate at the capacity of 40 megahertz, but give you the coverage of 20 megahertz without losing that sensitivity. And the same goes if you're using 10 megahertz channels. You want 20 megahertz performance, but you have 10 megahertz of receiver sensitivity, which increases your coverage. So here's a quick question from Chris. Does the rewrite cover mobile LTE or fixed wireless LTE? Both, actually. So it takes over an account of all the evolution that we've had since the beginning releases of LTE, and it takes advantage of the mobility side of things as well as fixed wireless. For example, we support X2 if you have a centralized core. We're working on X2 for distributed EPC now. And for what X2 doesn't know, that allows for seamless handoff from cell to cell, so you don't have call drops and things like that. So that's where it becomes kind of exciting. So jumping back over to the 10-watt radio is why don't we make a 20? Well, we actually do make a 20, and it's just in different bands. Honestly, usually band 3, kind of that lower frequency stuff, because they certainly do cover a lot better, and the UE can hear it. But when you add a carrier aggregation component to a software-defined radio, so say, for example, Huawei, ZTE, or even Telrad, if you have a 10-watt radio, that's it. That's all you get. And anytime you add a carrier, you have to split that power output amongst the carrier. So if you have a 10-watt radio and you want to add dual carrier, you now have 2 carriers that run at 5 watts each. You don't have 2 carriers that run at 10 watts each. So there's a cost. So now you're going from a 10-watt radio down to a 5-watt radio, which is why we came out with a 4x10-watt system that allows us to have dual carrier, each putting out 10 watts. So a good example here is I've actually deployed some 8x8 radios before, and they're 20 watts per port, and they can support 3 carriers. Well, when you put 3 carriers on a 20-watt radio, you now have 6.67 watts per carrier. So you don't really get 20 watts of coverage performance. And furthermore, to kind of talk about that is, yes, you can put out more power, but the subscriber radio still only puts out a maximum of 23 dBm. So even if you can hear the signal from your tower, the tower is not necessarily going to be able to hear you. And that's something you need to keep in mind. With uplink performance is generally the biggest struggle with making sure LTE capacity stay up there. You start installing a couple customers way out that you probably knew then you probably shouldn't have. We've all done that for that customer before. Like you knew you were pushing the limits and it come around to bite you. And that's often one of our biggest complaints that we deal with is customer cell capacity or operator cell capacity is low. And after I usually investigate from a support perspective, I can quickly tell that they probably put 2 or 3 customers on there they shouldn't have. And that's what's brought their capacity down. So even though you hear all this big stuff with high output power, I certainly caution you to watch out, because more power doesn't necessarily always mean more coverage. It usually ends up being more headache, especially if you're not planning accordingly, because you still got to account for the subscriber end of that system, which granted the subscriber could put out the same 10 or 20 watts and we'd all be in great shape when we could just burn through the forest that we're having to go through. And the reality is the 3GPP limitation in band 42 particularly is 23 dBm transmit power. For those of you that do have band 41 licenses, is actually what they call a class 2 transmission device, which you can have a UE that transmits up to 26 dBm. So it gives you 3 dB more transmit power, and that does increase your cell radius a little bit more. But you have to have that's specific to band 41. I think band 12, which is a public safety band, or 700 megahertz, which actually goes up to class 3, I believe, and that goes all the way up to 31 dB transmit on the subscriber side. So there's a bunch of different rules as we play around, and we are actually looking at doing a class 2 band 41 connectorized UE, so you can get not only more transmit power, but significantly you can add basically antenna of your choice. So that's a lot about the 10 watt. So you've also seen, for some of you that have been kind of following Baicells, we have the Nova 436, which is a 1 watt version of the same thing. It's just 1 watt per carrier instead of 10 watts per carrier. And all the same feature set, again, just lesser transmit power, and obviously lesser cost, more amplifier, more money. We have very simple math there. We have our current one that a lot of you may have today is our 2x10 watts, known as a Nova 243, and that one is a very unique product as well. And the new generation of that also comes with an SFP cage. The current one out there is just a couple copper interfaces, one for management and one for data. Then one of our most popular ones here in North America is the Nova 233, but that is slowly losing momentum to the Nova 436, which is the 4x1 watt to the left. But the Nova 233, the 2x1 watt radio, was our most popular one. Still a bulk of the installations out there do have that one. And the Gen 2 version, which is what you see here, has an SFP cage and a copper interface port on it. And we've simplified a lot of everything. So those of you that had the unfortunate pleasure of Gen 1, you certainly appreciate the power connections of Gen 2. Everything here is all you'll notice are on side doors on the right-hand side of the radio. That's where your data and your power go up in. There's no weatherproofing required. You just put the cable up there, screw the door down, and you're off and going. One of our favorite ones, at least one of mine, I call it kind of the micro pop small cell. So this is a band 42, 43 compliant integrated antenna. It's only 250 milliwatt transmit power, so 24 dBm, and it's got a built-in, I think, 14 dBi sector, maybe 16. I have to double check. But it's great little PoE plus powered. So for those kind of switches you run, but anything that supports 802.3 AT, you can power this particular radio off of it. Of course, we do ship it with a PoE, but if you have your own like Natonics or any other type of PoE type switch like that, you can power that off of this. And that's a very popular micropop solution for hitting 10 to 20 homes that you otherwise wouldn't be able to get to with similar non-line of sight characteristics. Anywhere from 1 to 2 kilometers max, I would say, is that one. Sometimes, depending on the scenario, you can probably push 3 kilometers, but I wouldn't get too crazy. So here's some of our other ones, and some of you, if you're following us on Facebook, you probably saw the LTU Spectra videos that were coming out last night. We're doing a field trial in northern U.S. It's our second one that we've done here in the U.S., and we're trying on continually. We actually have a very unique component to it. It is both FDD supported right now and soon to be what I'd call 3GPP compliant TDD, but we wanted to add the FDD support first. We thought that was pretty cool. So essentially what it means is you get 20 megahertz channel for the downlink and 20 megahertz channel for your uplink. So you have a base station capacity of about 150 megabits downlink and 75 megabits per second on the uplink. So that's a pretty cool radio. Also PoE powered, PoE plus powered, or you can feed it with regular 48 volt DC power. It has both options in it, as well as a fiber SFP cage as well. So that's a new one up and coming. I'll talk a little bit more about that. I even have some spec sheets I'll go over. Here's some other cool ones that we do for the mobility side of the house. We do a lot with the Neutrino. And our NutriCell is a relatively new product. This is a modular-based small cell. So for those that are interested in any indoor applications, you need to do anything along those natures. It has a built-in Wi-Fi module for hotspot systems throughout hotel, convention center, etc. And it has 3 blank areas to add LTE modules of any band that you can think of. So you may need a band 40 module, a band 42, band 3. And all 3 of those modules can be in operation at the same time. This is a PoE-powered small cell. Think of it as like an AP that you stick on a wall somewhere with LTE backhaul built in. The L-Cell 2 is kind of a cool product. I'm hoping to get a little bit more traction for buildings that don't have good internal wiring, but you want to deliver some LTE services to, particularly in the band 40 area, band 42, band 43 area. This actually has a power line carrier back to a central location, say the distribution room in most facility basements, and it will provide the backhaul and power just by plugging into the wall. So it's a very cool little product. Hoping that gets a little bit more traction here, and definitely has some good use cases in some of those older buildings that people try to cover that just have poor wiring at best. And there's some other small cells that we have. And it's a little cube, probably 3-inch, 4-inch by 4-inch by 4-inch, a little small cell, kind of a desktop backhaul solution. Also can be PoE powered. And here's the original L cell, which essentially is the world's smallest small cell. And we're challenging ourselves. We're actually making another small cell that can be powered off a USB. Another good question: which would allow one to select the appropriate small cell? Well, in short, good planning. So you really got to take a look at the area and such like that. Oh, I see here we got some more parts to it. Do we have a tool to dimension a network that factors radio channel? Yes, we do. So we have different tools that we use. We use one called EDX Signal Pro, which is kind of industry standard for the mobility section, as well as Forsk ATOL. Both of those pieces of software have modules that are designed for in-building kind of coverage as well as outside coverage, and we take into account we have to go out and buy clutter data and map accordingly. In-building becomes a little bit more challenging because that usually requires we can do some basic design, but in almost every situation I've come to, it takes some type of walkthrough to really understand the layout, despite some of the best blueprints that may exist. We still need to get in there and see what some of that material may be. Fire rated walls come into play from an RF perspective. So, and that's kind of where I sit and do most of my time is spent is in the RF planning side of the house. So then I help out operators make sure that their networks are optimally tuned based on the coverage they're looking to seek, and more so the capacity, because I base most of my designs on the 3 C's: is capacity, coverage, and cost. And we have to figure out a good balance between those 3 C's. Good questions. So the last but not least is the narrowband IoT. This particular one's actually it's a UE, so it's a backhaul subscriber radio to a typical LTE network, as well as a narrowband LTE eNodeB. So this one happens to run at 900 megahertz band, only uses 200 kilohertz channels, but can support up to 10,000 connected devices. So it's very unique. So say a good example for something like this would be you're in a city environment and you want to cover all the parking meters, something like that, or you want to see what the street lamp control could be, because this does support I think about 1.5 megabits per second, and if anybody's doing any SCADA, very low data consumption, that most of that stuff's measured in kilobits, not megabits, so it's perfect for items such as that. So here's some of our product that's currently shipping today. This is all of our Gen 2 platform. So we have our indoor unit here on the left, lower gain, smaller use case. It's a kilometer and a half at best if you're running at band 42 10-watt base station. Then you get into the higher gain outdoor units here. You have the Atom 14 and we have the Atom 19.5. A little caveat for those that are getting the Cat 6 version of this when it does start shipping. When you go from a Category 4 to Category 6, you do lose a little bit of antenna gain. So this drops to about 12 dBi from 14. So however, for many people using different reflectors, the same reflector bracket does work. We have tested. 24 volt PoE on all the outdoor units, and for those paying attention and happen to use Ubiquiti, you'll notice that the same exact power supply, and that was something we did on purpose. Given the readily availability of those power supplies and a lot of operators using that particular pinout currently. So we chose to use the same pinout kind of on purpose for those switching from those kind of technologies over to us. It would be a very seamless transition. Very quick to deploy. This one's pretty lightweight, a little bit lower cost. This one's a lot heavier duty, and you notice it looks a lot similar. I'm going to bounce back a couple slides to our integrated eNodeB. Same exact case actually, so this is just a different view of it. But it's quite heavy duty. It's got a good ground lug on the back, side door as well, SIM slot, etc. Oops. Any questions on any of the hardware so far? Okay, we'll keep moving on. It's going well. So LTE, non-line of sight challenges. A lot of you are probably here today because you hear about all the stuff. Oh, good question before I jump off. So can you explain some of the fundamental differences between Cat 4 and Cat 6 CPs, why and when you would choose one versus the other? Okay, that's a good question. So Cat 4, we'll start there, which is kind of what we came to market with, is a single carrier radio. So it cannot support dual carrier, which is its first component versus basically the Cat 6. They also only support up to 16 QAM on the uplink, which means you'll never see more than a certain speed on the uplink. Cat 6, on the other hand, and actually I will talk about our Cat 6. Our Cat 6 is actually also a Cat 6 or Cat 7, just by software update. And what that has the ability to do is to support 64 QAM on the uplink, which essentially will double the uplink capacity of that particular customer. So for example, if you have a cell site configured for only 10 megabits capacity uplink, just by having all these new Cat 6, Cat 7 units on there, and the eNode B was upgraded as well to support the 64 QAM uplink, you would be able to double your uplink immediately just by software without having to change anything else. The Cat 4 can't do that. It's hard coded at 16 QAM uplink. However, they both can interoperate, which is a good situation. You won't find a situation where if you have a Cat 4 location, the Cat 6 wouldn't work, and vice versa. They do offer backwards compatibility. However, you just won't be able to realize the same speed. So the long of it short is Cat 6 is capable of more speed, supports carrier aggregation, so in theory up to 300 megabits downlink, and up to, that's the sales number. In all honesty, you'll never see more than probably 160 megabits downlink on a dual carrier system, maybe 200 if everybody's keeping good optimization. Will Cat 7 do both 4x4 MIMO and 2CA? Yes. So there's two parts to that though. So yes is the short answer. The Atom 14 has a 4x4 antenna patch in it. The Atom 19.5 does not. That is actually still only a 2x2 antenna patch. But for those, if you are using 4x4, then this would be your guy here, the Atom 14. And of course, if demand is high enough, I don't see any reason. I'm pretty sure we're already developing the 4x4 patch for the new version for this. So I think we're playing with some Cat 12 and some Cat 16 product right now, but that's probably going to be a year or so out before we get to that point. And actually, I will little typo down here. This is a gigabit Ethernet down here, not 100 megabit. So we'll call that out. But long of it short is, if I had my way of things and cost was an option, I would just buy all Cat 6 because the Cat 4s are going to work just fine. Because it will be backwards compatible to operate at that throughput. But there's many cases out there, like don't go, if I was also operating an existing network, which I've done, which I started with Cat 3, I didn't forklift all my Cat 3 devices to go to Cat 6 or Cat 7 or anything like that. Only those customers that wanted to buy a certain speed plan, we would go and change them out. But if they're on speed plans that are only 20, 30 megabit down and a couple megs up, the Cat 4s are fine. They're going to treat you just fine. Nothing to really worry about there. I hope that effectively answered that question. If not, I'll try to rephrase it a little bit more. So as I said, long line of sight challenges. This is always a good topic. We still have to deal with physics at the end of the day. So I don't want anybody to come out of here and say LTE is going to fix all of my problems. It'll help you. It is not going to solve every problem you have. So I want to make sure that we understand that. And we'll help you try to figure out solutions that will get you there. But when a lot of people are trying to replace some 900 megahertz systems, for example, is you can expect about 75 to 85% of the same coverage of 900, but you're going to get probably 25 to 35 times more throughput. So there's kind of that, again, that speed versus coverage balance that you need to find. But you're not going to find a one-to-one solution going from something like 900 to 3 gigahertz, obviously, just because physics in general come into play. However, the reason why you get the advantage of LTE is able to do this versus some other 3 gigahertz product that wasn't LTE based is LTE does give you a 7 dB advantage over Wi-Fi, doubled with each modulation, as you can see in that last bullet point. So a lot of companies out there have some thresholds for DBM or RSSI of what they're comfortable installing their customers. Let's say, for example, you're running a 20 megahertz channel and you have a customer installed at -70. That's probably your cutoff point. Well, that's in LTE speak, that's about a -100 RSRP. And that -70 might net you some decent throughput overall, but we will have significantly better throughput on LTE. Now let's push it even further. Let's go to negative 80 RSSI. That's probably something you would never even install. Well, LTE, that's going to be around a negative 110 RSRP. Well, we'll pull 65 megabit all day on that, and it will be stable. You start getting much beyond that, it starts to get a little wobbly, but you got to understand too, how many customers are you installing today at negative 80 RSSI and being able to pull 65 megabit? Probably not many. I know from my perspective, just based on noise floor that existed in my market, is particularly in 900, that I couldn't go much beyond negative 70 anyway before just noise would kill my quality of links. And 5 gigahertz, forget about it. You know, the noise here was, most of my noise floors in city markets were in the 60s. So maintaining a negative 50 was almost a requirement. So outside of just, you know, LTE having better receiver sensitivity, that 7 dB advantage that we just talked about, and also taking advantage of MIMO, which is not unlike really anything else that's out there right now. But one thing that you'll find with LTE is they really standardize on slant 45 antennas versus just HV antennas. Now, for those that are working, you know, the coastal areas, particularly with tide, we have some good ones. I have a 12, you know, I can't speak in meters in that one, but it's about a 12-foot tide in the most eastern part of here in Maine, which plays hell with wireless links. Slant 45 helps address a lot of that, because instead of just being horizontal, vertical in the antenna patterns, being offset by 45 degrees, think of it as an X, makes for a much better propagation characteristics when I was shooting across water, which I had a lot of customers that would do. So granted, that's not special to LTE, but it is something that is kind of standardized. Use slant 45 antennas, you will perform better. But also, even in an urban environment, slant 45 has proven to perform better on reflective surfaces. For example, I was in Portland, Maine, which is one of our urban cities, about 65,000 people, which is our biggest city in Maine. So yes, I live in a small area. But there's many locations where I could never actually see the tower, but I would shoot off a building and I would be at full modulation, just based on the MIMO and the way that the slant 45 antennas would behave. So I pick up reflective signaling off different structures and perform incredibly well. And I remember one particular use case, we had 3 carrier aggregation running with a high category UE. We're pulling about 320 megabit down and doing about 35 megabit on the uplink, and had 0 line of sight. We were bouncing signal off 2 or 3 different buildings. So it's quite impressive in that regard. And of course, you just get dealing with trees. Like we have an abundance, and I'm sure you all do as well, of pines. And I'm not a fan of pine trees. I wish I could cut them all down. From an RF perspective, they certainly wreak havoc, as well as wet maples and oaks. But you know, it's a challenge that we have to bear. And you will find that when you work with LTE, sometimes actually the lower gain unit, like our 14 dBi unit, actually outperforms the 19 because it has a wider horizontal beam width to pick up more reflective power. So you will actually see some situations that not necessarily higher gain is better, that actually a lower gain unit may work better for you. So that's some very interesting little tidbits that we run into. So there's always similar situations, and I've come to find, having spent some time deploying different networks, that you're going to tackle every installation with a kind of a standard, then you have to kind of work off of it. So here's one of our customers today. Obviously, this one's got some pretty good line of sight characteristics, but he also has some non-line of sight customers. Was deploying both an indoor unit, as you can see here, there's nobody really in close proximity, but to have some success with an indoor unit was quite impressive. So he was seeing on average 60 megabits per second to most of his subscriber base. Now, this one's a non-line of sight area. This one's actually in Peoria, Illinois, somewhere right around that ballpark. That's where he's based out of. He's actually, in this case, replaced an old Canopy SM900 with a Baicells solution, and we went from barely having any connection to 1.5 up to 40 megabits per second. at 2.85 miles. So it's quite an upgrade going from one over the other. And grand noise floor kind of came into place here, but as you can see, the non-line of sight characteristics were certainly present on this particular installation. So before we move on to talk about Halo B, I do want to have a moment to just have some general Q&A. By all means, stick some stuff in the chat box. I'll tackle them kind of one by one. And if you have a particular use case that is of interest to you, by all means, this will be a good time to mention it and kind of what you're thinking about trying to accomplish. Do I have any recommendation for an on-prem EPC solution that if one has scale beyond the cloud core? There's a lot of good EPC solutions out there, many of which we've already done interoperability testing with. However, we're still toying with the idea of operating and selling our own local EPC. We actually do have it as a product, but it is sold to I want to say special customers, but very large customers, because it's also a very expensive product. There are some subscription-based systems out there. Athonet is a decent EPC that I've actually used and hold a high regard. Star EPC has been gaining a lot of traction. We've worked with them. If any of you guys happen to be using a Huawei or ZTE or Ericsson, Nokia, any of those EPCs, we've all interoperated with those. They all work as well, but they do come with a significant price tag. But for those who don't want to spend a lot of money and more interested in the subscription kind of EPC, I would take a look at kind of like a Athonet or Star EPC. By all means, take a look at other stuff. Have you received regulatory approval from the CRTC institution security establishment? So we preemptively visited or requested a meeting with them before we came to Canada. So what we have not done yet, though, is got our EPC certified with them, mainly because we haven't operated an EPC, an on-prem EPC in North America yet, and particularly Canada to be specific. So that is something that they have said when we do, that they want to revisit this and go through the testing. I've got some good questions coming in here. All right. We were not able to get the integration documentation. Any chance we can get the integration docs? I will have to check. That is above my pay grade. So I'll be completely honest with you. I'm not entirely sure. Is your radioed EPC in an active SRP program with Ottawa? Cannot comment on that one. Thanks for asking that. I know the EPC isn't. I can say that for certain. The other one I cannot really provide any comment on. Good question. When can I comment on that? That's another good question. I'll have to stick with my previous answer. I'm not sure. I'll have to look into that one. People that wear bigger suits and ties than me make those decisions. So. Which EPC do you currently support? All right, so from an EPC perspective, we kind of take the position that we're standards-based. So we will work with any EPC that's willing to work with us. So if there's a particular one that we haven't worked with, we are happy to engage with them to do some IoT testing to make sure that we will support them. But in short, we've worked with a number of them already. Like I said, ZTE, Huawei, Ericsson, Nokia, Athonet, Star, and there's probably a couple others that just can't come to mind. So another follow-up question in regards to the testing and whatnot is from the Halo B adoption. So from the way we've been told and understood, and I'll hopefully get some clarification from the documentation standpoint, is because the EPC is not centralized with a Halo B system, and that you will have the option to actually keep the management of that local, is that we don't have to follow the same criteria. Now, I'm waiting for some clarification on that, because the EPC mechanism has no way of phoning home anywhere other than to the management control system, otherwise known as our OMC. And we understand, particularly with the sensitive nature in Canada in and around that, that we want to make sure that that we are all set there. So am I saying that Halo B is compliant in Canada today? I want to say yes, but I do not quote me on that at this time. I'll work with the rest of the team to make sure that we get that proper documentation out there to give everybody a little bit more peace of mind, including myself. Any chance we can IoT with Aragon Networks EPC? Yeah, sure. By all means, send us a note and we can work with that. I think Giancarlo will be the appropriate contact to start with there. Then we will go on from doing some IoT with that EPC.
That must be from Tomer?
You're good. It's almost like you know.
Yes, I do. I do. Thank you.
So Giancarlo, we do have some homework here. And I'll get this chat box sent over to you, but we need to go make sure that our Halo B solution goes through the regulatory approval with CRTC, ISED, and the Communications Security Establishment.
Yeah, which I would imagine is no problem, given that it's a distributed on-prem solution. There should be no issues with that.
That is my thought, but I want to make sure we get a formal literature out for that. I think that's appropriate.
Mm-hmm.
Need to introduce me to EPC4U. Well, that's a catchy name. Okay, any other questions before I move on to talk about Halo B, since it's obviously a topic of discussion anyway? All right. So Halo B. So granted, we owe you some paperwork here, but all I want to do talk about it. It's one of my favorite things ever. It's something I was pushing for essentially since starting here at Baicells a little over a year and a half ago. Is I've been seeing a continuing trend of distributed EPC, which is really what a Halo B means. Granted, this is a use case that talks about unstable backhaul and things like that, but it really is much bigger than that. And what I mean by that is it pushes your control further and further to the edge. It's pushing your EPC computing further and further to the edge. And what that does, it actually helps with backhaul requirements. So instead of locations maybe requiring 500 megabits or a gigabit backhaul to be able to take on all the consumption, you may be able to cut that in half. So you may be able to go from 250 to maybe 500 megabits total, because now you're into more of a front haul situation and be able to avoid all the unnecessary backhaul, because all the QoS and shaping's happening at the edge versus happening back in centralized location. So it makes your backhaul more efficient. What it also does, it starts adding other features in, like layer 2 support, which I don't want to get confused with bridge mode support. They're two different things. A lot of people are asking us for layer 2. When we say we're going to have a layer 2 solution, that means you'll be able to broadcast and everything, DHCP, like true layer 2, over things like GRE or VXLAN and all that fun stuff. But what a lot of people are really wanting is not layer 2. They're actually just wanting us to be able to pass through the public IP to the customer radio while still being able to manage the radio. That's the more popular request, but that's often gets confused with layer 2. So we'll be able to support both of those in a very upcoming software release. So it also takes the headache away for those. Why we push this is the big expense of a centralized EPC is just that it is quite expensive, and it's still one point of failure. Granted, you could have redundant EPCs, but now you're talking twice the cost, and it still needs to be. You still have the very large expense and still some risk. You only have the 2 EPCs. With Halo B, essentially everything is its own, well, Halo. It's its own system. It's got its EPC, it's got the MME, it's got the DBU. The only thing it does not have is the HSS. However, in a very soon-to-be software update, you'll be able to manually import the SIM cards into the eNodeB directly. So right now what's happening is the Halo B actually talks back to the OMC system, which is our operational maintenance control platform, which holds all the SIM cards that you have set up. And what will happen is when a device comes to attach to the Halo, if it exists, it'll automatically attach. If it has not downloaded this information before, it will go to the OMC system, whether it's in the cloud or on your local network, and it will then be available for sync. And once it syncs, it has the information forever. So if you lose the OMC system and BOSS system, doesn't matter. The system will continue to operate independently. The only thing it will not do is get any changes. So say if you change a customer speed from 10 megabit to 15 megabit on the downlink, and the OMC system is down, or the connection between the OMC and that Halo is down, they will not sync and get the update. However, the next time they come online, they sync, then the package plan will change. So it's very unique in that sense. And that's where we're getting more and more configuration and availability between the two, because you will be able to have that kind of data control locally. You won't have to be dependent on the cloud, or you'll be at least at a very minimum dependent on your own cloud should you choose to use your own system. But the OMC BOSS system is going to be commercialized into a product that can be installed on your system. Essentially, long of it short, if you want it on your own system, you give us a server or a VM, we'll come in and install it for you, get it off and going. We're hoping just to make it a VM, because that's the big delay in making its commercial availability. It's just give it a VM that you can spin up and you're off and going to the races. So that's kind of what that's waiting on, and G and Carl will have more information on that as we get a little bit further down the line with its development. But understanding that it's a big thing that I've been pushing for a while, and I'm sure G and Carl will echo that. It's not lost on me at all. Will there be an API available to remote eNodeB HSS configuration? To the ENB directly, no, but there is an API to the OMC BOSS system that is publicly available now. So if you have a billing system that you're using today, for example, and you don't have API integration, by all means, open a support request and get that API documentation. You can begin the implementation component to that, because it will make your life a lot easier. Cost of OMC BOSS. So that is, well, I don't want to say the $1 million question, because I think we'd all just leave the call if I said $1 million. I'm not entirely sure, but it's not going to be, from my perspective at least, and this is with my operator hat on, I don't think it'll be unreasonable, but it will be, I don't even want to throw out a number, but I think the MSRP is going to be around the, I'm going to say high, just because I don't want to get in trouble later. I'll say $20K, but I'm going to say very, very high, because I know if I say the number too low, I'm going to get yelled at later. So let's just say that for now, but I suspect the street price will be later, less than that. I'm sure G and Carlos cringing in his seat right now.
I don't have price confirmation, so I'm not cringing nor smiling. I'm just reserving that for later.
Yeah, so it's not commercially, it's not commercialized yet, but once it is, it'll be reasonable. If anybody pushes for reasonable pricing for this market, it's going to be me. I'm quite vocal about it. How many eNodeBs per OMC BOSS? That's another good question. So that's all following up to some of the cost structure. We may have multiple tiers of the product, so it's reachable for those that may only have 100 eNodeBs versus the same person that has 10,000. So that's what we're trying to figure out. So capacity, not cost. So really, it's all dependent. The biggest component to what the OMC BOSS can support is not necessarily the software, it's the hardware platform it exists on. So for example, there's tens of thousands on our cloud-based system that we monitor and manage, but we've had to spin up a few load balancing VMs to take on that, particularly for the database functionality. So with that said, it really depends on the architecture you have available per VM. Well, I mean, yes, if your server is limited to 8 gigs of RAM and you need more than 8 gigs, then obviously you're going to need to spice up your server a little bit. So, of course, I think most people are deploying physical servers a little bit more than 8 gigs of RAM nowadays. All right, so talk about the Halo B, jumping back to the NAS is processed by Halo B, eNodeB. The UE will always be online, of course, unless the eNodeB goes off. Only users under the Halo B will be affected when a failure occurs. So if you lose one eNodeB, only that particular one is going to be the one of issue, naturally. However, that doesn't prevent if those customers see multiple eNodeBs. If it sees another eNodeB, it will go and authenticate to that eNodeB and download its information again from the OMC platform. So it doesn't. That is one advantage. One of my favorite advantages of LTE that actually do work. If you lose an eNodeB and the customers can hear another one, they will jump over. Granted, they may not be getting the best performance, but slow speed better than no speed in some of those cases. So you can build in some level of redundancy. That's just not really easily done with Wi-Fi based systems. The cost for adding Halo B is significantly less than if you were to buy a centralized EPC. I don't know what it equates to in the Canadian dollar, but it's $250 US per each key, and significantly less cost obviously going and spending $250,000 on an EPC. And I think it's $199 US per key if you buy 10. So there's obviously a different price break. So I'll let my Canadian friends here do the conversion. I know it's always ever-changing, it seems. UE moving and switching towers to eNodeB, is that an LT or Halo B functionality? So it's actually both. So we're adding an additional functionality into Halo B, and that's the cool part about it, is it will, from a distributed EPC standpoint, we'll be supporting X2, which is another interface that allows the eNodeBs to communicate with each other to inform them that there's a handover opportunity taking place. However, if one of the eNodeBs just go offline, the UE makes the determination that, hey, that's not there anymore. Can you get me something else? And it will just do that. But what Halo Bs will do with the X2 interface is they're constantly talking, and the UE is getting feedback as well. And what will happen is the eNodeB will essentially tell the UE what to do. It's going to based on similar metrics that you will be able to set. So say, for example, a triggering event, this customer is going to be on cell 1 with a -70, and here's cell 2 at -72. Unless you have a triggering event to happen with 1 dB difference, that user will not move. But say if you had a triggering event of 2 dB difference, the cell's going to say, all right, this here is something better at 2 dB. Should I begin a handover? And it's going to say, okay, let's scan a couple more times to make sure that's a real number. And if it is, then we'll start the handover process and ultimately hand over to the other cell. Follow-up question to that was UE moving, switching towers, is that LT or Halo B functionality, even if the OMC and BOSS is offline? No, if the OMC and BOSS is offline, the Halo has no way of getting that information unless you manually import it, which you will have the option to do, I think, in the next software release, which is due out in the first couple weeks of August, I believe, maybe towards the end of the month, because usually they always tell me that. So yes, if manual, yeah. But if it is still reachable, the OMC system is still reachable, then yes. Another thing you can do is, if you only hope to be manual, is you actually can just import the SIMs to multiple eNodeBs, and they will be able to hand off ahead of time. So that is an option as well. So if you're completely remote and there's no Halo OMC connection, then you had 3 eNodeBs on one site, you could duplicate the SIM that you had to every eNodeB, and it would be able to switch between the 3 eNodeBs without issue. So multiple APNs, that is another part. That's what we were talking about earlier when I said the bridge mode and layer 2 functionality. So we'll have an APN, basically stands for access point name, and you can have as many as you want, but we're starting with 2. And what that does, we'll have one APN, let's say a management IP, and one APN that supports bridge mode. And that'll pass through the IP to the customer router, so it gets rid of some of those NAT considerations that you'll be running into now. And this is kind of what the design overall looks like from a Halo B perspective, and how it works is how things still go up to the OMC boss. And again, this can be either cloud-based or local. Right now, it's cloud only until we officially commercialize that as a local solution, which we are aggressively working on. And all the other fun stuff that we have going on here. Can you use follow-up question? Can you use multiple PAN for routing to wall guarding content, say if billing is overdue? We have people do it differently. I would have to think about that. We have people that go to wall gardens today. I'm just not sure if that's how they're doing it. So I'll have to check if it can be done by APN. That's actually, oddly enough, you asking this question, Chris, is a good one, because that's exactly what I did. But I had the Athonet centralized EPC when I did it, and I sent the naughty customers to a special APN that would only take them to our main website and the payment portal. And once they made payment, it sent them back to reprovision their SIM to another APN. So it's doable, but I don't think it's doable with the cloud EPC or even Halo B at this time. But now that you brought it up, I'm going to submit it as a feature request. So from an upgrade standpoint, for those of you operating today, it's very simple. And for those who've gotten a chance to meet me personally, I'm not very passionate about the license fees. In fact, I hate them. I hate them all. I'll be very honest about that. But in this particular case, I made exception to my own rule only because I understand the value here of not having to go and buy your own EPC and how much that really costs. I've really spent the money doing it before. And what Halo B is going to be able to afford you. So this is one of the few exceptions to my own rules where I actually don't mind a license fee because I see what's going on, and obviously the resource that are tied up from our development team into this particular platform. We're putting a lot of resources into this. Understanding that still tough to choke on for some people, particularly when it comes to license fees, because I'm not a fan of them. You'll hear me echo that time and time again. Not only on webinars, but certainly in internal calls that I push for none of that nonsense. So that is the process right now, is we have eNodeB, gateway distributor, in this case MBSI WAV. They'll hook you up with a request. They'll basically send you the serial number, ask for your serial number. They'll submit that to us. We will in turn send the key to them and on to you. And it's a pretty straightforward process to integrate. It's usually just a software update. If you preload the key in OMC, everything goes online, and next thing you know, you just bring yourself a Halo. So that's all I got. I'll leave it on that last slide just so it looks good on your screen. By all means, if you have any more questions, it's a good time to ask them while you've got my undivided attention. I'll give it a moment here, because I know some people type faster than others. But I do want to thank everybody for jumping on today, listening to me talk for the last hour or so. I do enjoy doing these. It gives everybody a good perspective of kind of what we're up to. So question, where did I have my network? So, sure. So actually both the networks I had were in Maine, oddly enough. So my first one, I joined a company in my very young years in '97, and we were a primary BreezeNet shop, and Giancarlo probably remembers those days. Then we grew into Trango and some other hardware from there on, even Alvarian, even Microtik. We played around with that, and naturally with Ubiquiti when they came out with the NS series way back in the day. then sold that in 2014 and 2011. In late 2014, we started an LTE company using exclusively band 41 spectrum that we acquired through the entire state of Maine, and learned a lot throughout that process, and as far as deploying and how to properly deploy LTE networks. I can tell you, if none of you have been to Maine, it's not to say that's the same as Canada, but it's still pretty damn cold here in the winter. And we have a lot of good topography challenges and certainly trees. I see Nicole, yes I will. All right, not seeing any other questions. I do appreciate everybody's time. My email address, I don't have it on the slide, which is kind of bad on my part, but Cameron.Kilton@Baicells.com. And by all means, you saw Giancarlo, maybe I'll flip back over there just for a second so you can have his contact information back on the screen. Right there.
Cameron, I can also add in yours and Giancarlo's contact information to my webinar follow-ups.
Oh, you are just a peach. Exactly.
No problem. I appreciate you taking your time, Cameron. Thank you to Giancarlo as well for chiming in when he was needed. I appreciate everyone attending. This webinar has been recorded, and it will be available shortly for replay.